Now, I would like to introduce you to Hach TOC Product Manager, Jason Padilla.
Thank you, Molly. Managing industrial water quality has never been more important, complicated, or expensive than it is today. Most industrial operations require water for their processes, utilities, or cooling, and at some point, all that water must be treated for reuse and sent back into the environment. To present on how online monitoring can control industrial water quality, we have David Horan, who is the CEO of BioTector Analytical Systems. BioTector was recently awarded the Frost & Sullivan Product Leadership Award for their expertise in the TOC analyzer market. David, we're all looking forward to hearing from you. The time is yours.
Thank you, Jason, and welcome to this presentation coming from Cork in Ireland. So today we're going to look at utilizing online monitoring to control industrial water quality. So in industrial water, there's lots of different types of water. So there's water used in processing and for processing. There's cooling water to cool down the process. There's heating water. There's water used for cleaning. You can get some returned condensate water. There's surface and storm water when it's raining. There's grey water. Of course, there's a lot of wastewater. And there's water that can be used for recycling. So what we're going to look at today during this presentation is how online total organic carbon, TOC, can play a part in managing all these different types of water. So there are challenges in industrial water management. And of course, industries, plants and processes are complex and variable. Information is required to make operation decisions. And of course, this information needs to be in real time. It needs to be quick and easy to disseminate. It must be accurate. And above all, it needs to be reliable. If you're going to make operational decisions, you need accurate and reliable information to do that. And of course, as the saying goes, if you can't measure, you can't control. And that couldn't be truer for industrial water management. Inaccurate or delayed information can actually lead to a whole host of issues and costs, such as lost product literally being drained out of the plant in your wastewater. You could have damage to valuable equipment like boilers. You could have wasted energy, wasted water itself, and you could have overload in the wastewater treatment plant. And of course, that leads to a whole range of other issues and could actually stop production. So there are a number of measurements out there, and we're going to have a look at BOD, which is biological oxygen demand, COD is chemical oxygen demand, and of course TOC, total organic carbon. So BOD first of all, well, it is a laboratory measurement. It takes 5 days, so it's quite a long test to do. Cost per test is estimated at about $45 per test, and even after the 5 days, its accuracy is about plus or minus 15%. There are interferences to BOD, such as nitrite, sulfides, chlorides, irons, and acids, and of course the laboratory process needs to remove or try to reduce these interferences. And that's the reason, because it takes so long, that COD came about. So COD, again, it is a laboratory measurement. It takes about 2 to 3 hours. So it is much quicker than BOD, but it still is a lab measurement. Cost per analysis is about the same. Accuracy is a little bit better at plus or minus 8%. It does still suffer from interferences, and so the laboratory process has to try and mitigate for these. And with COD, there is a hazardous waste generated, which needs to be disposed of correctly. And this is the reason why a lot of industries are now moving quite quickly over to total organic carbon. And the reason being is that TOC, it's a very quick measurement, less than 7 minutes. Because it's fully automated and it's online, the cost per analysis dramatically drops. So it's less than 1 cent per analysis in online monitoring. Its accuracy is much improved at plus or minus 3% of the actual reading. The only interference is from inorganic carbon, and that's easily removed by just adding acid as part of the process. and there's no hazardous waste generated from a TOC analysis. There has been a number of studies and reports into the best measurement, the latest being from the Instrumentation Testing Association, ITA, and their report concluded that TOC, it is an alternative to BOD and COD, that TOC is more cost-effective, more accurate, more timely, with less interferences, and has the capability to be used for process control and real-time monitoring. So what exactly is total organic carbon? Well, the definition is it's a measure of the carbon content of dissolved and undissolved organic matter present inside in a water sample. The standard method in order to measure this parameter, it's an infrared measurement of CO2 gas generated by oxidation. So basically you take your sample, you oxidize it, that breaks down the organic carbon into CO2 gas, and then you measure the CO2 gas in an infrared CO2 analyzer. And that gives you your TOC result. So based on that information, you'd have to wonder, why is TOC monitoring not used more widely or more frequently? And in my opinion, TOC is one of the most underused parameters in water analysis because it's extremely useful. The problem is not with the parameter itself, but with the technologies that were trying to make this measurement in the past. So the technology trying to make the measurement let the parameter down in effect, and it caused sort of a bad reputation for online TOC, and that is the reason why it's not being used more widely until the advent of the HAC BioTector, which we'll discuss today. Before we go into that, we're going to have a look at some of the traditional or conventional technologies just to understand why the technology let the parameter down. So the first one we're going to look at is UV persulfate technology. So UV persulfate uses a UV light and sodium persulfate reagent. They combine to oxidize your organic carbon into CO2 gas, and that CO2 gas is then measured, and the result is TOC. So the issues with this technology, well, first of all, it's a weak oxidation method, and so it's really only suitable for very clean applications. It requires filtering to protect the analyzer, and if you filter, you're removing what you should be measured. You're actually removing that undissolved part of the sample, which should actually be included in the measurement. Salts totally stop the measurement process and basically kill the analyzer. Turbid or dirty samples will block the UV light, and again that will stop the measurement. Over time you get scaling of the UV light, and that leads to needing a lot of recalibration to offset that scaling of the UV light. And also the light source itself reduces in power, so you need recalibration to offset that as well. Overall, that results in a high maintenance analyzer, and also it's not able to measure and include volatile organic carbons, which can be important in a measurement. Next, we're going to look at high temperature oxidation or thermal oxidation. So with this method, you use high temperature, maybe above 900 degrees C, in order to burn the sample, convert all the organic carbon into CO2 gas, and again you measure that CO2 gas, and that's your TOC result. So here the oxidation process is actually very powerful, so it will be able to oxidize everything. The disadvantages with this technology is more around the physical and mechanical parts of it, because it needs a very, very small sample. You must inject less than 10 microliters of sample, and in order to do that you need a delicate sampling system. And of course that leads to small moving parts and a lot of maintenance. Again, you need filtering to protect this analyzer, and you're removing what should actually be measured. Salts and other material are actually going to coat the inside of this furnace, which means you're going to have to replace or frequently clean this reactor. So overall, it's mechanical items that need maintenance are the issue with this technology. And with the buildup of salts and other material, you need to frequently recalibrate the analyzer, as its signal will drift quite quickly over time, especially if there's salts in the sample. traditional and typical online issues that have stopped this parameter being used to its full extent relate to frequent maintenance and service, so high cost of ownership, low reliability leading to a lack of trust that the analyzer will actually be running when you need it to run, signal drift, I mentioned recalibration, and if you're recalibrating the analyzer, you're going to lose confidence in the actual results provided. If you're recalibrating it every week, you're going to lose confidence in what it's actually showing you on the screen. And filtering, of course, if you use filtering, you've got a maintenance item because you have to clean and replace those filters, but you're also removing those particulates that have organic carbon in them, and therefore they should be measured. That's the reason why we at BioTector Analytical Systems came up with developing the HOC BioTector. We used a breakthrough TOC technology. It's two-stage advanced oxidation. It's extremely powerful oxidation. It's a patented method. This method uses ozone and sodium hydroxide to create a hydroxyl radical. So when you mix ozone and high pH solution like sodium hydroxide, you create this hydroxyl radical. The hydroxyl radical is extremely powerful. It breaks down the sample, and it also keeps that reactor clean, so you never have to maintain or replace that reactor. So it's the hydroxyl radical does the oxidation. The advantages of using such a method is that it's extremely powerful. So like high temperature, it is very powerful, so it can break down all types of chemicals and samples. It's completely unaffected by salts, up to 30%. Both accuracy and physically, it's not affected by salts. It can handle samples with oils, fats, greases, particulates, and now that allows you to use these technologies in a whole host of new applications. You don't need any filtration or delicate sampling systems, so straight away you're getting a more representative sample, and you're also removing moving parts and items that need maintenance. The reactor itself is self-cleaning because of the oxidation process. It actually self-cleans that reactor. We've got a self-cleaning sample line, so every part of the analyzer that comes in contact with the sample is cleaned every single measurement. And all of these features lead to low maintenance. So you only have to maintain this analyzer every 6 months. You do a 6-month service and you recalibrate the analyzer at that 6-month service. High reliability is the big feature of the technology. 99.86% uptime, and that's a certified uptime. So here you get to see the HOC BioTector on the right-hand side there. It's got a top box for electronics and a bottom box for the wet chemistry process. It's a patented technology. Our main measurement is total organic carbon. We can, using our technology, add a module to measure total nitrogen. We can add a module to measure total phosphorus. We can correlate quite easily to COD or BOD. If you want those results on the screen, we can actually have that result outputted instead. We can measure total carbon, inorganic carbon, and we can include and actually measure the volatile organic carbon. If it's the chemical industry or petrochemical industry, they may have VOCs in their sample, and that needs to be accounted for. So we can do that. In total, we can measure up to 6 different process streams, and we're cleaning each sample line in between each stream measurement, so we're making sure that there's no carryover from one stream to the other. So because of this completely new technology, we're able to satisfy a whole host of commercial objectives that are out there. So we can tick boxes and work in different applications that TOC analyzers just couldn't do in the past. So for example, our analyzers are used for energy optimization, plant yield increase, process control and process efficiency increase, product loss detection and reduction. We're going to actually look into product loss detection in more detail now in a minute. Protecting plants like boilers, we're going to look at that. Real-time information for operators and management to use. Recycling of stormwater, condensate water and cooling water, and we're going to look into that. course, overall you have a reduction in water consumption then. And the wastewater treatment plant, we can measure the influent and effluent and in process in the wastewater treatment plant in order to control its operation correctly. And of course it can be used for regulatory compliance. So we're going to go straight into the product loss side of things, and we're using, in the last number of years, we have a lot of clients using the BioTector to detect and reduce product loss. We're going to look at one here from the dairy industry. So in Ireland we do have a lot of dairy industry, so it's something we know a lot about, and we've proved our analyzer in the dairy industry reducing product loss. So this particular process that we're going to look at on the left hand side of the page, they have 7 BioTector analyzers installed. This dairy plant has a 2012 revenue of $1.02 billion. Its net profit in 2012 was $30 million. By strategically locating these 7 BioTectors, they were able to reduce their product loss by 15%, making them an annual saving of $1.5 million. So a huge amount saved in product loss reduction. Because they made those savings in product loss, they actually were sending less wastewater down to the treatment plant, so they realized further savings down in the treatment plant of about $140,000. So in total, they're saving $1.64 million every single year with these 7 BioTector installations. So that's contributing to their net profit 5.5%. So an absolute huge return on investment. These analyzers would have paid for themselves between 3 and 6 months. Another one we have on the right there is another dairy processor. They have 11 BioTector analyzers, and they put them in 2012, and in that year they increased plant yield by 3 to 4%, and of course they are contributing BioTector in order to help them to do that. So again, another rapid payback on their investment. So how are our clients actually getting these results from online TOC monitoring? So we're going to look at how they actually achieve this. Well, they've taken a totally different view of wastewater. So traditionally, industry looks at wastewater as being a headache that belongs to the wastewater treatment plant, and it's their capacity is their own problem. So it's sort of separated out, and whatever wastewater goes down there, the treatment plant has to look after it, and that's their job. Whereas a totally different approach of looking at it is thinking of wastewater. Wastewater is water with your product inside in it. So there's actually dollars inside in that wastewater that probably shouldn't have gotten there in the first place. There's also probably energy in that wastewater that probably shouldn't have gotten there in the first place. So there's a new emerging viewpoint of the dollars in wastewater. So if you think of your pipe sending wastewater straight down to the wastewater treatment plant, and you look down into that pipe and into the water there, and actually start thinking about that water and thinking how much product is actually lost in there. How much product have I brought in the door, processed in my factory, and because of leaks, spills, operator errors, overflowing vessels, a whole multitude of different items happening that shouldn't have happened, I've actually put my product right into the wastewater, and it's gone, and I'll never realize the value of it. So looking at that, of course there is treatment required for it, and there is a cost for that treatment. You could also look at that wastewater and think of the energy that went into processing that you've now lost by having leaks and sending that down to the wastewater treatment plant. So there's energy lost. And of course a section of that wastewater could be suitable for recycling, so you could actually reuse it again. So it's a different way of looking at wastewater. So to continue on that theme, if we take a dairy plant, for example, again, and you look at the amount of BOD that wastewater treatment plant is treating, and of course treatment plants do often think of BOD or COD. So they may be treating millions of kg of BOD. Or in the US, of course, they could be treating in a typical dairy plant maybe 3 million pounds of BOD annually. Well, if you look, where did that BOD come from? BOD doesn't just materialize. It has to come from somewhere. So there's something that has created it. So in a dairy plant, to create 1 kg of BOD, you actually need to lose 9.26 litres of milk. So 9.26 litres of milk lost down the drain via some leak will create 1 kg of BOD. So if you look at in US terms, 1.1 gallon of milk lost will create 1 pound of BOD. And a typical dairy plant in the US, medium-sized dairy plant, would be treating about 3 million pounds of BOD a year. So they're losing about 3.3 million gallons of milk in order to create that BOD. So now you're equating your wastewater with the product that came in the door and got lost and ended up in the wastewater treatment plant. And you can do that for milk, but you can do it for all different types of chemicals and all different types of industries. And we've done that in the chemical industry. One particular plant was using a lot of acetic acid, and we were able to equate that you need to lose 1.41 litres of acetic acid to create 1 kg of BOD. You then look at their treatment plant, see how much BOD they're treating, and start calculating back how much product they are probably losing during the year. Same with ethylene glycol. You've got crude oil there in the refining industry. You need to lose half a litre of it to create a kg of BOD. And of course, that's a lower level because it's a concentrated oil, it's concentrated organic carbon. And the sugar industry, you need 1.4 litres of liquid glucose to create 1 kg of BOD. So if you start looking at what is actually in each industry's process and start looking at what amount of that material is needed to create a kg of BOD or a pound of BOD or a pound of COD, you can start actually working out what is the percentage product loss, and you can start targeting that and reducing that loss. In order to do this and to realize these savings that we're talking about, you need production and wastewater treatment plant functions to work together to optimize and realize these savings. And online TOC is the perfect tool to actually help those functions work together. It enables shared process insights, accountability, and increased efficiencies. So if we look at a typical chemical plant, you've got a number of different processes there. So we've got 6 processes that we can see in this example. Each of those are sending their own individual wastewater down to a collection point, and from that collection point, it's fed into the wastewater treatment plant. The wastewater treatment plant treats the wastewater, and then the water is discharged out to the river or the sea. And typically and traditionally, it's at the discharge point where TOC analysis has been used. A lot of times it's used before the treatment plant in order to control the level going into the treatment plant and actually protect the treatment plant and make it more cost effective in running the treatment plant. But actually the savings, and about 7 or 8 times more savings than the treatment plant, can actually be realized if you start monitoring back up on each of the process plants' wastewater leaving the plant. So if you measure each of those drains coming out of the process plants, you can actually immediately identify when there's a leak, when there's a spill, when something has gone wrong. In real time, you can send that signal or alarm into the people in that process plant. They can look at it. Operators can immediately try and find where the leak is coming from and to try and stop that valuable product being lost down to the treatment plant. So you can take immediate action, look at what happened then, and with management work out a plan to prevent it happening in the future. But that's where the real benefit of TOC actually comes, is by measuring right back up into the process. So it actually becomes a management tool. You have your process, you're going to have incidents. The TOC analyzer picks up on those incidents. Operators have real-time reliable information that they can respond to immediately to stop that incident occurring. That information can be passed up to management to ensure that that problem doesn't reoccur, or at least to try and reduce that problem, and that minimizes losses and of course gives huge savings, and those savings go straight to the bottom line. So all of this saving that we're trying to make, it's relying on the information from the analyzer, and that's absolutely critical. So the analyzer has to be reliable and accurate. If you've got good information and trustworthy information coming from the analyzer, operators and management can then very easily work together with that information and realize these savings. It does hinge on the technology and the measurement of the analyzer. And that's where the HOC BioTector comes into play. And with this oxidation technology that I discussed and the ability to handle oils, fats, greases, salts, low maintenance, all these items allow this technology to be used exactly as we mentioned there, as a management tool. It has to be able to survive in the type of environment it's going into, and it has to be able to survive the type of samples that it could be measuring, which we've got some examples over on the right. Again, you could have high levels of fats, oils, particulates, greases, salts, calcium inside in that. The analyzer's got to measure it. It's going to be measuring it 86,000 times a year, measuring it every 7 minutes. It has to be a robust oxidation technology that can handle it, and then you get your confidence in the results, and then you make the savings. So that's the product loss side of things. We're now going to look at some other water quality applications where you can use TOC analysis. You've got condensate return, cooling water, and surface water. And we're going to look at each one of these individually. So condensate return water. Why measure it at all? Well, the main purpose of the measurement is to protect the boiler. The boilers are extremely expensive and important pieces of equipment. If you get leaks in your heat exchanger, you want to know about them straight away to prevent those leaks going into the boiler where your organics can actually damage the boiler. You want to reuse that condensate water as much as possible and to get as much of the energy out of it as possible. You also want to reduce the amount of makeup water that you're going to use and the chemical additives that you need to add to that makeup water. So you want to reduce both of those because you're recycling the water as often as possible. If you do that and you recycle the water as much as possible, you're actually going to reduce the wastewater treatment costs because there's less water being sent to the treatment plant. So we have here a typical diagram of condensate return application. You've got your boiler there on the left, usually very expensive. You've got your makeup water coming in and anti-corrosion additives. It's heated into steam. That steam goes through your heat exchangers, and you're going to heat or cook the process in those heat exchangers. On the outside of the heat exchanger, you're going to have condensate return. That's going to come back, and ideally you want to send that straight back into the boiler to recirculate it again. So it'll come back at maybe 90 degrees C. You want to put it in the boiler, heat it up again, and reuse it straight away. So you're getting the most out of that heat. You're only having to top it up in the boiler, basically. The purpose of the HOC BioTector in this application is to watch for breakthroughs. So if you have a leak in the heat exchanger and you have process breaking through into the condensate line, you want to stop that from getting into the boiler, as it will damage the boiler. So you want to pick that up in your TOC analyzer and divert it down to drain. Just a couple of application notes in the US for condensate return water. So the first one we'll look at is a chemical plant in Texas in the US. So this chemical plant, like a lot of plants actually, they purchase steam from a cogen plant. They use that condensate or that steam in order to heat up their process, and then they return the condensate back to the cogen plant. They will get penalized if their TOC is in exceedance of a certain point. So they want to make sure that they're not actually having a breakthrough in their heat exchangers, as that will result in fines from the cogen plant. This particular chemical plant in Texas, they wanted to control and they wanted to monitor their condensate water. What they put in originally was UV persulfate TOC analyzers. And I mentioned earlier in the presentation that UV persulfate analyzers need a lot of recalibration, and they also have a lot of downtime. The actual recalibration cost this plant $52,000 a year. So a huge amount of cost just trying to keep those analyzers accurate. They were also losing money on maintenance and paying for service engineers and things like that. Ultimately, they just had no confidence in the measurement. And of course, if you're paying all that money for a recalibration, you're not really going to believe the results out of it. So the solution was to install the HAC BioTector. They did that because the BioTector only has 6-month calibration requirements and you maintain it only every 6 months. They were totally able to eliminate penalties and calibration costs immediately. So there was an immediate return on investment. So they started replacing all their UV persulfate analyzers with the HAC BioTector, and they're extremely happy with their product now. Another application note is from a food processing plant in Chicago. It's actually a corn processing plant. This was a very interesting one that I visited a number of times. They had a very expensive boiler, and they were trying to do the right thing again. They wanted to control and monitor their condensate water, but they used high temperature TOC analyzers originally. And because of a number of different factors which we were able to work with and show them, the high temperature analyzers were giving false high measurements. And this resulted in no confidence in the accuracy of the measurement. And of course, they were doing a lot of recalibration and a lot of maintenance. So while they were maintaining the high temperature analyzer, they were draining their condensate down to the wastewater treatment plant because they weren't measuring while they were maintaining. And of course, the false high readings were incorrectly draining a lot of the condensate down to the wastewater treatment plant. So the net result of this was that 59% of their condensate water was actually diverted to drain every day. So we knew that there was something wrong here. We put in the HAC BioTector. Because of our uptime, 99.86 uptime, and the reliability of the machine, management actually became very confident in the results from the HAC BioTector. So they became very confident in the results, and they actually realized that their condensate water was perfectly clean most of the time. They actually only needed to divert 5% of it daily. So therefore, they were able to recycle 95% of their condensate water on a daily basis. And that gave them astronomical savings. It was $34,000 a day was the savings they were able to make from putting in a HAC BioTector. They put in about 7 of them, and their return on investment was literally in weeks. And that comes down to technology. They want to do the right thing. Both of these applications wanted to do the right thing. They wanted to measure. Unfortunately, the technology that they selected let them down. Now we look at cooling water. So again, why would we want to measure this? Well, there is a big cost saving from water reuse in this application. So cooling water is one of the largest water uses in the US, so it makes perfect sense in order to reuse it as much as possible. And of course, there's energy optimization in doing exactly that. There is also environmental compliance. So if you look at the diagram below, on the left-hand side, you see cooling water may be taken in from the river, brought through a heat exchanger, and then it might be sent back out to the river. Well, if you get a leak in your heat exchanger, you're actually going to be sending your valuable product literally down the river. Also, of course, you're polluting that river, and you could get an EPA fine for that. So you'd use analysis in order to see what's the quality of the water coming in, what's the quality of the water going out, and therefore, is there a leak in my heat exchanger or not? Over on the right-hand side, you can see a different method where the water comes in from the river. but it's recycled. So instead of going back to the river, it actually goes to a cooling tower, and then it's brought back as cooling water again. And here you'd measure the quality of the water coming in, the quality of the water going to the cooling tower, and checking for any spikes or leaks in the heat exchanger. In that application, I've seen our VOC option being used as well to see what levels of VOC are going to the cooling tower, and that can be very useful information too. Finally, we look at surface water. So again, why measure it? Well, decisions need to be made here. You can surface water, and of course it could be storm water, it might be called in the US, and it's basically when you've got high rains or storms there. So that water can either be reused if it's clean. If it's not clean and it has high levels of TOC, BOD or COD in it, you can send it to the treatment plant before discharging. Or if you measure it and you see that the levels are low, you might decide to bypass the treatment plant and just send it directly out to the river or waterways. So you see on the left-hand side, you've got a number of buildings. When it rains, you've got a number of paths and surfaces where all that water is going to end up and collect and drain down along. Then your TOC analyzer measures it, and it decides whether to recycle it, send it to the wastewater treatment plant, or send it directly out and discharge directly to the river. So that's the purpose of it, and it allows you to get the most out of your surface water. There is another surface water application, and that's within the airport industry. Quite an interesting application and something we've been doing a lot of work on in the last number of years. So I just thought it'd be worthwhile bringing this up. One application note is from a large international airport in Oregon in the USA. So they want to monitor the surface water to detect and monitor glycol levels during de-icing season. So during the winter, they're going to spray the airplanes with glycol. That glycol is going to go onto the ground, and then when the rains come or when the snow and ice melts, it's actually going to come away as surface water and go into the drains around the airport and ultimately end up in the river or the creek nearby the airport. So of course it needs to be monitored to make sure that they don't get a charge or end up an EPA charge or end up polluting the rivers or creeks nearby. So this particular airport was using a BOD type analyzer to manage this de-icing runoff. And I mentioned earlier that BOD really is a laboratory method. It's not suitable for online analysis. And because of that, they had a huge maintenance spend annually in order to try and keep these analyzers running. And they still didn't have great accuracy, so they didn't have a whole lot of confidence in what the analyzer was telling them. So we gave them a HAC BioTector in the winter of 2011-2012. They did a full study on the results and a comparison from TOC over to BOD. And we've got a quote here from the de-icing operation manager that states that they made a decision to purchase the BioTector because they're more accurate, more reliable, and require less maintenance than the BOD meters that they were using for the previous 10 years. So this is a very interesting application, and of course it is quite difficult, and I can understand why other technologies did fail or did have difficulties in this application, because glycol, it's very sticky, has an extremely high level of TOC in it. So when you do get a hit of glycol, the analyzer has to be able to clean itself up and clean that glycol out of it, clean the sample tubes itself, or else if you don't have self-cleaning technology, you are going to plug up the analyzer in no time with glycol. So there's a number of different applications where companies have been able to use our product, and because of our oxidation benefits, put TOC in places that TOC was never used before, such as the product loss monitoring. I'm just going to leave you with some of the key points of the HAC BioTector patented technology. So low maintenance, it's only 6 months service required, and you do that calibration during the 6-month service. So the analyzer keeps its accuracy in between services. It's high reliability, 99.86% uptime, and that's certified by the MCerts, which is a body in the UK. It's a robust piece of equipment used for clean and dirty water analysis because it can handle salts, fats, oils, greases, and particulates. No pre-filtering is required, so you get a fully representative sample, and also you remove all the maintenance and hassle associated with filters. Simple operation. It's easy to use, easy to service. It comes with a range of intelligent diagnostics. You can actually remotely access our analyzers via the web or via the intranet or ethernet and look at the results from your desk or from your home and see how the analyzer is running, what the results are. You could check the fault archives. You could actually stop and start the analyzer or change it from measuring one stream over to another stream. So, thank you very much for your time. I hope that information was useful. If anyone has any questions, please let me know.
Thanks, David. We did get some questions in during the webinar, and I'll go ahead and start asking you some of those. The first one is, my sample is very dirty. It is oily and has large particles. All other analyzers attempted in this application have been too maintenance intensive. Is online TOC analysis even an option in this case?
Thank you. Well, that's a very interesting question. And here, this is a case where somebody sees that TOC analysis would be useful to them, but of course they've probably had or heard about poor experiences with other TOC technologies. So yes, TOC can be made, and TOC measurement can be made with these types of applications with fats, oils, and dirt inside in it. And two-stage advanced oxidation inside in the HARC BioTector is now able to make that measurement a reality, and for that customer to be able, or that person to be able to use our technology to make that measurement. So yes is the answer there now, Jason.
I've got another one that's somewhat related. It says, do I really need two-stage advanced oxidation if my sample water is clean or looks like drinking water?
Okay, so two-stage advanced oxidation, yes, it's a fantastic chemistry. It's two-stage advanced oxidation gives you the reliability and the accuracy that you want in an analyzer. Because it's a clean application, what we've actually done with our product is we use one product, which is the B7000, and that's for wastewater. And then we have another product called the B3500, and that's for clean water applications. So this question looks like it's an application for clean water, and therefore the B3500 is an ideal product for them. It still uses the two-stage advanced oxidation, but physically inside in the analyzer there's a number of items that you don't need when you move from wastewater down to clean water, and therefore we were able to develop a separate product for clean applications, which is about a third of the price stripped out of it.
Okay, here's one that's related to that one, and it says, why couldn't I just use conductivity to measure and control the quality of my condensate return water, which is a clean water application?
Okay, and I have seen conductivity used quite a lot, particularly in condensate return applications. It is now being replaced quite a lot with TOC, and that's because conductivity itself, that's a measurement and is ideal for detecting products of corrosion. Products of corrosion are ionic, so conductivity measurement will pick up on that, but it is severely limited in its ability to detect organics. So the majority, it's organics that actually damage boilers and cause problems in boilers. So you want to pick up on organics, but organics are non-ionic, and so they will not be detected at all by conductivity. And they would actually give a false positive, signaling that the water could be recycled, whereas it's only a TOC analyzer that will actually pick up on those organics and tell you that you need to protect the boiler and send that high level down to the wastewater treatment plant.
I've got two here that are somewhat related, so I'm going to combine them into one. It says, what type of acid are you using with your system, and where does the ozone come from?
Okay, so the reagents in the Hach BioTector is sulfuric acid. It's 1.8 normal sulfuric acid, and we use also 1.2 normal sodium hydroxide. So they're the two reagents that are used for it. So ozone, I think the other part of the question was, where does the ozone come from? So we've actually got an ozone generator inside in the Hach BioTector. So what we do is you'll hook up either instrument air to the analyzer, or we'll have our own oxygen generating system. So we'll flow oxygen through our ozone generator. It goes by corona discharge method, high voltage. It converts oxygen into ozone, and then that ozone is used during the reaction.
Okay. What is the estimated overall cost per test for a BioTector?
So the estimated cost per test, it's less than 1 cent, so it's about 0.75 of a cent. And we calculate that basically by looking at the amount of measurements that the Hach BioTector makes. So it makes about 86,000 measurements a year. We look at the reagent consumed on it because we know that. We know the maintenance, which is a 6-month service kit and a 12-month service kit. And when you combine all those factors together and you divide it all down into the number of analysis, you will get a cost per measurement of 0.75 of a cent.
Sounds like a very cost-effective measurement.
It is. It does a lot of work and provides a lot of information.
Here's one related to the service of the analyzer. It says service and calibration is required every 6 months. Can this be done by on-site employees, or does it need to be done by a Hach service technician?
We've set up our systems to be easy to use, so you can actually do the calibration on site very easily. You can actually program the analyzer to automatically do a calibration if you want to. So while the analyzer doesn't need it to be done only every 6 months, you can, if you want to, calibrate the analyzer on a monthly basis or on a 3-month basis or whatever you like, and you just put a setting inside in the analyzer, and it will count down to that and then automatically come offline, do the calibration, and automatically go back online again. So it's very simple to do themselves, so you don't need a trained Hach person necessarily to do that.
Here is another one. It says, what size particles can this analyzer handle?
Well, the smallest part inside in the BioTector is 3 millimeters in size. So that's the tubing, we'll say, and the valve where the sample is injected into the reactor. So we would suggest that the biggest amount of particles that we will take in is a 2 millimeter soft particulate. So we can take 2 millimeter soft particulates into the analyzer, oxidize them, measure them, and in that way you're actually making a total organic carbon measurement because you're including particulates.
Okay. What is the detection limit of TOC or of online TOC? Okay,
so we mentioned we've got 2 products. So the B7000 is used for wastewater application, and that has a minimum detection limit of 0.6 of a ppm. Then we've got the B3500C, which is for condensate and cooling water type applications, and because they're much lower levels, our detection limit in that product is down at 60 ppb, so it's right down in the parts per billion measurement range.
We've got some more here. It says, I would like to measure or monitor our RO distribution system for bacterial growth. Can this indicate, can you use this measurement to indicate that when they start to have bacteria growth?
Yes, so the great thing about TOC is it's organic carbon. There's organic carbon in everything, including bacterial growth. So if there's bacterial growth happening, and we're monitoring that water, we will pick that up as TOC, and that will again that will be an indication that there is growth happening there. So yes, we can and we do a lot in monitoring before the RO and after the RO to see exactly what's happening and how it's performing.
Here's another one. It says, can we use this on RO washes to save water?
Well, again, we are using this technology on RO washes, so, or we'll say on reverse osmosis, again using it before it and after it to see the performance of it. In order to reuse more water, I would assume that they can, if you have the information there and you can see how clean the water is, that you can actually recirculate that back and reuse it again.
Here's a question on condensate return. It says we use TDS to measure condensate return to protect our boiler system. Is the TDS measurement a good way to protect the boiler?
Well, not necessarily. Your total dissolved solids, it wouldn't be the ideal measurement to make because you really want to find your organics. It's not, we'll say, solids that are actually damaging the boiler. It's organics, and organics can be dissolved. So if you don't look at the dissolved part of what's going back to the boiler, that's where the organics are. The majority of organics are actually dissolved in water, and therefore you need to make that TOC measurement to pull out all that. It goes back, I suppose, to the definition of TOC. It's the organic carbon in dissolved and undissolved parts of it. So you need to get that dissolved part of it, and you can get that only with a TOC analyzer, which oxidizes it all, brings it out as CO2 gas, and makes the measurement.
Here's one regarding TOC, BOD, and COD. How does TOC relate to COD and BOD?
That's a good question, and it regularly comes up. So they're all related to each other. So if you take one particular chemical, it will have a fixed TOC reading, and there'll be a fixed correlation factor for that chemical for COD and BOD. And typically you'd multiply TOC by 2, roughly around 2, 2.1, 2.2 maybe, to get BOD, or you'd multiply your TOC by around 3 to get COD. So every chemical has a fixed correlation factor between them all. But of course, what you've got to look at is what is the mixture of chemicals inside in your wastewater. And there is a method that we go through in order to understand that and to see exactly for that industry and for that application, what exactly is the correlation factor. Is it 3.1 or is it 3.2? That's part of a procedure that we do when we're installing the HAC BioTector. Why is there that relationship? Well, there is a relationship from TOC to COD and BOD, because if you look at what COD and BOD are, it's oxygen demand. So whether it's biological oxygen demand or chemical oxygen demand, it's oxygen demand. And the biggest element that causes an oxygen demand is carbon. So carbon is by far the majority oxygen consuming element in a sample. So if you have high TOC, you have high oxygen demand. So by measuring the biggest contributor to COD or to that oxygen demand, you now have a huge piece of information. If you actually measure total nitrogen and total phosphorus, you now have a real online COD or BOD analyzer, because the next biggest oxygen demand is from nitrogen, and the one after that is from phosphorus. So by measuring all three of those, you have a real online analyzer, and BioTector is the only technology in the market that can measure all three, TOC, TN and TB, in one analyzer using one sample and one oxidation method. And of course then you're giving out results really as COD and BOD if you want to.
Okay, David, we got a couple more questions in here. When would I use multi-streaming, and how can two-stage advanced oxidation measure 6 different streams without carryover between each stream?
Well, when can you use it? Of course, the answer to that is wherever possible. If you're buying a piece of equipment like this and you're putting money into it, there's huge cost advantages in order to make the most of it and to measure more than one stream. So if you can if you have a number of streams that are nearby, and it's all down to distances, if you have streams that are located near each other, well, then it makes perfect sense to have a 2-stream or a 3-stream or a 4-stream biotector. What you would look at there is the speed of response. You want to make sure it's going to be just under 7 minutes per analysis. So it's a batch measurement, so it'll be measuring one stream, then the next stream, then the next stream. So you want to make sure that overall the cycle time is okay for that application. But if it is, then it makes perfect sense to measure as many streams as possible if they're located close by. So the analyzer itself, it can draw samples, we'll say up to ideally around 4 meters away from it. If you have samples that are farther away, we do have a special Venturi vacuum sampling system that will suck samples from 70 meters away to the analyzer. So now you could definitely do multi-streaming whereby you're actually sucking different samples from different parts of the plant 70 meters over to the biotector and making the measurement. And of course that really makes the most out of the analyzer and the functions of the analyzer. When it comes to carryover, and that's extremely important because other technologies like UV persulfate and high temperature, they're not able to self-clean every part of the analyzer. So if they try to do multi-streaming, they will have problems with carryover. With our oxidation process, the actual hydroxyl radical and the 2-stage advanced oxidation we're using, it keeps the reactor clean. And then at the end of the measurement, we've got a spent acid, which we use to clean back the sample line. So we'll clean it right back to where the sample came from. So if you've got a 6-stream application, you're actually going to be cleaning each of those lines or each of those sample tubings, in making sure that you don't have carryover from one stream to the other. So we've been able to prove that with the HARC biotector, we can handle one sample that could be 40 times higher, so a 40 times magnitude of TOC than another sample stream, and we won't have carryover between those 2 sample streams. Physically, how we measure 6 streams, we've got selection valves inside in the biotector cabinet itself. So we've got selection valves that switch from one stream to the other.
I've got one here. Is TOC better to monitor bacterial growth than an ORP monitor?
Well, they're making 2 different types of measurements. So ORP is oxidation reduction, and that's typically used, we'll say, maybe inside in a wastewater treatment plant. What I would say is they are 2 different measurements. What we're going to be measuring is the organic carbon inside in it. So it really depends on the process and whether an organic measurement gives them better information about how their treatment plant is performing over an ORP one. I wouldn't be an expert on that.
Okay, we got time for one more question, and then just a quick note that any questions that are left unanswered, we'll be getting back to you guys individually with those answers for you guys. Here's the last one. The detection limit for oil samples or oil-rich flow. I assume that this is asking what's the limit on measuring TOC with a biotector?
So because we'll be measuring oil as organic carbon, so it's going to be a dirty application, therefore it's going to be the B7000 analyzer that you'd recommend for that application, and that will measure down to a detection limit of 0.6 ppm.
And then how high can that go?
With our technology, we're able to go all the way up to 100,000 ppm TOC. Very rare that we would ever need that. I think we've only got a couple of analyzers out there doing it, but our technology allows us to go as high as 100,000 ppm. Okay,
David, that's all the questions that we've got time for. I'd like to thank you for spending time with all of us today. For more information regarding the HAWK TOC analyzer, please feel free to visit hawk.com/online TOC guide. All of you will be receiving an email with a link to the online demand version of this presentation, as well as a PDF of this PowerPoint, a fact document, and a Q&A transcript from this webinar. Lastly, please take a moment to complete this survey that each one of you will get that will appear on your screen at the end of this webinar. Again, thank you for taking the time to learn more about how online monitoring can control industrial water quality. Take care, and we'll talk with all of you soon. Thanks.